Why me? Hello, my name is Rhys Duncan and I am a Year 13 student at St Peter's School in Cambridge. I'm working towards my NCA Level 3 certificate this year, studying physics, calculus, computer science, earth and space science and chemistry, as well as doing a staff-funded Stage 1 Advancing in Mathematical Science course at the University of Canterbury. Additionally this year, I am into the scholarship exams for physics, calculus and earth and space science. So a bit about me. I have grown up in a family of physicists and have always had a passion for the sciences, particularly physics and astronomy. I regularly read about physics in books and popular media, as well as subscribing to channels online, and so enjoy discussing ideas about physics with my peers and teachers. Since last year, I have taken Earth and Space Science as an NCA subject, and this has been an interesting opportunity to complement my knowledge with the principles of astrophysics. This passion for physics and astronomy means that I naturally have a career goal of working in physics or astronomy, a research role being my ideal career. Adding to and enhancing my own scientific interests, I have strong skills in mathematics and computer science. Next year, I plan to go to the University of Canterbury to begin a physics degree. As a physics student, problem solving comes naturally to me. I have always involved myself in problem solving competitions, from the BP Challenge days at primary school to the Y Mathematics competitions, and for the past 2 years, the New Zealand's Next Top Engineering Scientist competition, where I have enjoyed using coding skills to model scenarios and contribute to the team's outcome. Throughout my secondary schooling, I have consistently been awarded high distinction in the ICATH mathematics and science competitions, as well as being successful in many other competitions. In 2015, I was a member of a St Peter's team that won the University of Waikato ChemQuest competition, and also got 100% in the Australian chemistry competition that year. I have always maintained high standards in my academic program at school. At senior prize givings, I have been awarded course prizes for Year 11 Physics and Chemistry, for Year 12 Physics, and as well as the Excite Trust Science Award last year. I have received excellence endorsements at both Level 1 and Level 2, and because of this have received a Scholar's Tie and Silver Owl from St Peter's. I have further distinguished myself with my science fair projects over the years. My very first project in Year 8 was an investigation into the surface tension of various liquids. This earned me a gold award at the East Waikato Science Fair. My attention then turned to the Waikato Science Fair when I began at St Peter's School, and in Year 9 produced a project called Blown Away, an evaporation experiment. This project was judged the runner-up to the best in fair and was the best physical world exhibit. I attended the Kudos Awards evening as a result of this and was very interested by all the different presentations and enjoyed talking with the scientists. Year 10 involved a project titled Aroha Air, where I developed a particulate monitoring system and measured the air quality in my hometown of Te Aroha. I won a place in the Realise a Dream event that year and thoroughly benefited from the privilege. I remember thinking how great it would be to participate in the event as a Year 13 student. Even though the format has changed, I have always aimed to make this application to the Royal Society. My science fair project this year is central to my application. It has incorporated so many aspects of science that I am passionate about: physics, astronomy and computer science. The project was called Spectroscopic Analysis of Wolf-Rayet Stars. In this investigation, spectroscopic analysis of the 2 Wolf-Rayet stars was carried out, and variability in emission line intensities determined. Emission lines are an unusual feature in stars and define a Wolf-Rayet star, as well as its intrinsic variation in luminosity, as it is a variable star. Process spectra were found to have spectral emission lines that accurately correlate to each star's spectral classification criteria, and variations in intensity noted. My investigation showed that useful spectroscopic analysis can be carried out using simple astronomical equipment and software. So why me? I hope that I have shown a true passion for science and how I have the problem solving and communication skills in order to contribute to New Zealand's scientific research in the future. I'm excited about where this may take me. Thanks very much for listening.